Okay, so in this video, we are focusing on the down the group. Okay, we would like to take a look on the patterns in the periodic table down the group. In the last video, we are talking about across period, which means this. You will take a look on the horizontally, and down the group means what? Take a look downward. Okay, down the group. So in this video, we are going to take a look on those elements which are already grouped together. So what is mean by grouped together? So we follow the steps of the Mendeleev 151 years ago. So to come up with the periodic table. So just recall your memory about what the Mendeleev have done is to come up with the periodic table based on this, right? They based on the difference in the chemical properties. So at that time, Mendeleev have already found that lithium, sodium, potassium, rubidium, and cesium, what we are now going to talk about it as group 1 metals. Okay, group 1 metals, they have similar chemical properties. How about group 2? Group 2 is beryllium, magnesium. They will see that zinc and cadmium is not group 2. But it will be quite fascinating to see Mendeleev, even though at that time they don't know anything about electronic arrangement. He was still able to come up with that idea of grouping them. How about group 7? Group 7 is here, right? Fluorine, chlorine, bromine, and iodine. Okay, we have got similar results. So do you find any noble gas here, right? No noble gas here, right? So because it's too stable to be discovered at that time. So of course, Mendeleev do not have that gases in mind, so they cannot get any patterns for further study. But you may see that one is so fascinating is that Mendeleev have nearly successfully have grouped those elements according to the chemical reactivity, and here comes the modern periodic table, group 1, group 2, and group 7 elements respectively. But how would you understand in terms of the modern science while we come up in the late 19th century, when something to early 20th century, so you get to know something more like electrons. And later on, scientists have come up with the saying that the chemical properties, whether or not they have got chemical reactions with the other substances, mainly depend on the number of outermost shell electrons. So this is a very important saying. So in other words, if you want to take a look at group 1 elements, they have 1 outermost shell electrons, so they have similar chemical properties because they have it's related to the same number of outermost shell electrons. So today, in this video, we would like to talk about group 1 and group 2, and mainly metals. Okay, mainly main group metals to come up with how similar the chemical properties is, and also some of the comparison of the physical property. So alkaline metals, what is that? Why is it said alkali? Group 1, okay, alkali. So remember the spelling, ALKALI, alkali,鹼金屬. Why is it like that? Among those 6 elements, 1, 2, 3, 4, 5, 6, okay, from lithium, sodium, potassium, rubidium, cesium, francium. Francium is radioactive, so they react with water to form alkalis,鹼. So鹼is something in which will react with salt as acid to form salt and water as the only product, with a pH value of this alkali greater than 7. So you know that it's alkali, you know in form 2. So we call that alkaline metals,鹼金屬. Now you will see the following table to see some of the similarity and some of the differences between those. And what I want to mention with you is on the physical property. So what you will see is that the electronic arrangement of them, they are quite similar in terms of the last digit. Last digit is the number of the outermost shell electrons. Okay, they all have just 1 outermost shell electrons. So they are solid, Melting point and boiling point, they will be quite low when you compare with commonly found metals, just like iron, copper, gold, silver, in which their melting point it is more than 1,000 degrees. Okay, some of them even rises to 2,000 degrees. So when you compare with those commonly used metals in transition metal, okay, when you compare with this with group 1 metals, you may find that they are generally low at melting point and boiling point. But how about density? Density is rather low when you compare with the transition metals one. Okay, so you may see the first of all, but within the group they are not the same. They will have a trend like this. Okay, they will have a decreasing trend down the group. Can you see that? And while for density is an increasing trend. Okay, we have got increasing trend down the group. So this is what are the findings of group 1 metals. Now at room temperature and pressure, they are silvery white solid when polished or freshly cut. Okay, but once you see the diagram, you will see what? You will see the outer layer here. It is just a metal oxide. It will give you a dull color. It will give you a dull color. So all they have the relatively low melting point and boiling point when compared with other metal. What I want to mention with you is on the transition metals as a reference. Okay, when you compare with transition metals, it is very, very low. And while the melting point and boiling point decreases down the group, they are soft and can be cut with a knife. And please circle that it is very special properties. Okay, for the common metals, they are quite hard and strong, but for group metals, they are quite soft and it can be cut with a knife. They have very low set density when compared with other metals, just like lithium, sodium, and potassium. Can you see that? Now, lithium, potassium, and sodium, we have got the density smaller than 1 gram per cm cube, which is less dense than water. Which means that once I put the metals onto the water, it will float on the surface. It will float on the surface. Okay, so this is what very special about group 1 metals. While if you are going to put a piece of copper and iron, so of course they will sink because of the very high density, much higher than the density of water. So this is what I would like to talk to you. Now, in the following video, I will show you the brief chemical properties of those group 1 metals, especially with reactivity with water. Okay, let's check it out.
There are 6 alkali metals: lithium, sodium, potassium, rubidium, cesium, and francium. They're all soft metals which can be cut with a knife. In air, the elements quickly become coated with compounds that form on the metal's surface. Here, for example, is lithium. When we slice it, you can see the metallic luster, but the black coating quickly reappears. Sodium is kept under oil to prevent reaction with air. Again, when we cut it, the metal surface can be seen. But this time, corrosion occurs even more quickly. With the next alkali metal, potassium, the corrosion in air is so quick that it's hard to see the metallic luster at all. As we go down the group, the elements seem to react more quickly with air. Now let's see another reaction of the alkali metals, the reaction with water. We'll start with lithium. The metal floats on the water and reacts with it, giving off hydrogen gas. Now for sodium. The same sort of thing happens, although the reaction is a bit more vigorous. All the alkali metals react with water in the same way. Let's see an equation for the reaction. Hydrogen gas is produced, and the metal dissolves to give an aqueous cation with a single positive charge. Now for potassium. This time you'll see a flame. The heat given out by the reaction is produced so quickly that the hydrogen gas catches fire. It burns with a lilac flame. The next element is rubidium. This time we put a safety screen between us and the reaction. You can see that things gradually become more terrifying as we go down the group. Let's try cesium, our fifth alkali metal.
So you may see this one a very fascinating video, right? So you may know something about the reactivity of alkaline metals. Okay, so we would like to show you this one again. So what are they? They all react rigorously with water. So actually, why we have got an explosion? Now it's because of very hot. Okay, it will give out very. We will call that exothermic 放熱 exothermic reaction. EXOTHERMIC 放熱. So a type of reaction to describe the heat, a large amount of heat is given out. While I will have a heat and I've got hydrogen, it is a flammable gas. So you may see the air around. We have got oxygen, so we have got fire triangle, so that they will have explosive reaction. And what will happen left behind is besides hydrogen gas, here comes an alkaline. So this is what we call the alkaline. Sodium hydroxide. So once I put a potassium inside that, so what will happen? Potassium will react with water to form potassium hydroxide and hydrogen. Okay, so you may see something like this. Okay, hydrogen and water to form potassium hydroxide and hydrogen. So this is what we would usually express it in terms of the chemical equations. They all react with nonmetals to form compounds we call the salt yin. So that's why sodium chloride is just one of the example. It's just a chemical combination between sodium metal and chlorine gas. Of course, you may think of some other metal just like potassium. So if I react with potassium with bromine, for example, and other halogens, right? So what we get, we call that potassium bromide. Okay, with the formula, so you will be listed with the formula like this. KBr, right? Okay, so it is potassium bromide. So I just named a few. Now, and this is what the properties of that. First of all, react with water to form an alkaline solution. Second is to react with nonmetals to form salts. Do they have the reaction with acid? Yes, but the reaction with acid will give a explosion. Okay, so this reaction is very, very dangerous. Okay, so we are too dangerous. So we would never attempt it. Okay, even though you know that metals in general, many metals can react with acid, we will not do that type of reaction because it's too dangerous. Okay, so they are very reactive metals and must be stored in the paraffin oil. It can be extracted in the fractional distillation of crude oil, a type of fractions in the crude oil. To prevent them from reacting with air, it actually is oxygen, air, and the water vapor. So why? Because either air, we will have oxygen, we will react with sodium metal to form sodium oxide. And how about water vapor? Of course, you know that the reaction here is here, right? So we react with water vapor to form hydroxide, a type of alkaline with hydrogen gas. So that's why you may find that those metals, they are very, very special. They should be stored under paraffin oil. So in our chemistry lab, we will see sodium and potassium is commonly stored in the paraffin oil, just like this. It's for safety reason. Okay, and otherwise, once you take it out, what will happen? It will tarnishes in air very easily. Tarnish means becomes dull. So easy. Why is it dull? Because of the metal oxide can be formed. Okay, so this is what I would like to talk to you. One more thing about video is not just explosion, but also for the reactivity will push things. So reactivity, which means the vigor of the reaction. Okay, it measures the vigor. Okay, the vigor of the reaction, how vigorous it is. So reactivity will push things. Okay, so this is reaction, RACTION. I write down the short form only. So the reactivity of these metal will become more and more vigorous, and finally it will be explosive. So explosive that it damages the glass, right? The trough. Okay, so why is it like that? The reactivity of metals increase down the group, or you use this term, increase down the group. So the increasing trend, reactivity trend from and this for group 1 metals is shown. Okay, it is shown from lithium to potassium is shown by the reaction with water. So you may see that the down the group, they will see the more vigorous reaction will be seen. Okay, so this is what we talk about group 1 metals. How about group 2? Group 2 metals, we call it as an alkaline earth metals, 鹼土金屬. So remember the term, remember the spelling of the term. A little bit different is of the term alkaline, Line, Line. While you compare with alkali, it is Alkali. So it's a little bit different word. Okay, so you need to be very aware of it. So what we are now referring to is the last digit. The outermost shell reaction number is 2. So if I'm radium to radium, again radium, just like francium, is radioactive. So they are found in the earth and react with water similarly to form alkaline. So we call it alkaline earth metals. Okay, alkaline earth metals. While you compare those melting point and boiling point, when you compare with group 1, you may see that are slightly higher than group 1. Okay, higher than group 1, but still lower than transition metals. So we see that. And similarly, then you have got a decreasing trend down the group, While for this one, they will no longer float on water, but are generally higher than density, higher than group 1, but lower than transition metal. The physical properties, first of all, they are silvery white solid when freshly polished or freshly cut. Low density when compared with group 1, but higher than density than group 1, but lower than transition metals. Okay, so I would like to repeat once that one. Transition metals, when compared with this, it is lower. When compared with this, it is higher than. Okay, higher than group 1. So they have all relatively low melting point and boiling point, while the trend is decreasing down the group. Okay, so this, but generally they will be higher than group 1 elements. So that's why if you have magnesium strip, you can hold it in your hand, right? But you cannot hold the sodium, right, because of reactivity. And this one, magnesium, is rather is harder than sodium. Sodium can be cut as a knife. Magnesium, the texture of it is very, very similar to the commonly used metals. How about chemical properties? The chemical properties, they are usually reactive metals. However, in the same period, so what you will see that the reactivity is lower than group 1 elements, which means, for example, if you want to compare sodium, it is the reactivity of this one, magnesium, is more reactive. Okay, in terms of their reactivity. So which means magnesium is more. Sorry, there should be less. Why would I write it down like this way? So I write wrongly. So I would like to write it once again. That is sodium. It is more reactive than magnesium. So magnesium is less reactive than sodium. Okay. So this is what I would like to talk to you. And what's next is about the reactivity with water. You also react with water, but this time I change it to hot water. And the product is generally the same. It is metal oxide together with hydrogen gas. So for this reaction, it's quite similar to group 1. Okay, very similar. But you may find that I would like to have a more harsh condition, to start the reaction. Now, all reactive metals, then they react with dilute HCl, dilute hydrochloric acid, to give hydrogen gas. So you may see here, for example, magnesium reacts with hydrochloric acid to form magnesium chloride. It is a water-soluble salt. So that's why once I put a piece of magnesium inside that, finally it seems disappear, but it's not. But it doesn't disappear. It forms a new compound. We call that magnesium chloride, but it dissolves in water. So from seeing, we cannot see the magnesium metal change to another compound, right? Instead, it dissolves. Okay, the magnesium ribbon dissolves. 溶解. So it is a phenomenon that you may see while we put the piece of metal inside that. Together with hydrogen gas, the colorless gas bubbles, it is hydrogen gas. Now, you may use the similar equation to relate what will happen if I change the metal from magnesium to calcium, and the acid is the same. So you may get what? Calcium react with hydrochloric acid. What will you get is calcium chloride together with hydrogen gas. Very similar chemical property, okay? Hydrogen gas. So, what's next is number 4, is very similar to group 1. They all react with non-metals to form a compound source of very, very similar. So, magnesium plus chlorine to form magnesium chloride, calcium plus chlorine to form calcium chloride, etc. And the reactivity of that, it increases down the group. Okay, it increases down the group. So the increasing trend is from barium to calcium. So you may find that the trend increases down the group. So this is what the end of group 1 and group 2 metals. So shall we spend some time on doing the checkpoint? Now, checkpoint. Sodium and magnesium, they are two common metals. A student want to compare the reactivity by putting them into cold water. What groups do sodium and magnesium belong in periodic table? So sodium and magnesium, they belong to two different groups. So what is that group? Group 1 and group 2 respectively. Remember, capital Roman. Now metals, they are usually shiny, but sodium is gray in color. Why? But it's not that the sodium is gray. Originally, sodium is silvery. But why is I will see it's gray? Because something has reacted. Okay, so what reacts with sodium? Yes, that's right, the air. What gases in the air with it will react? React with oxygen. They will react with oxygen in the air to form what? Sodium oxide. Okay, which is gray in color. So in your exam, if I ask you guys to write down the equation to support the idea, the equation will be this: sodium plus oxygen to form sodium oxide. So this is the equation. C. The student put magnesium into a test tube with cold water. State the expected observation and explain your answer. Magnesium, cold water, sorry, no reaction. But you have got two observations. One, it sinks. Okay? And two, it has no further observable change. So we have got that two observations. Observation 1 is sinks. Observation 2, no further change. You have to relate the answers, okay? You have to give me 1 and 2. Explain answers. Why? Okay, for it is a matter of density, right? So magnesium has a higher density than water. So it sinks. And why is it no further chemical change? Because you may see that magnesium does not react with water. So it has no further change. Okay, so you may see that. So remember, you are going to put that to give the observation, and second give me y, and which should be matched with each other. For example, it sinks the density. You are going to use this. Does not react with water, so you are going to explain why it has no further observable change. Now D, and the student put sodium in the cold water in the trough. The sodium moves around the water surface and then dissolves to the give solution. One other observation, now besides moving, besides dissolve, what other observation do we see? Yes, because it flows on water, because it's too hot, finally it melts to a silvery ball. So the temperature is quite high that it exceeds its melting point of sodium. Because for the sodium, the melting point, take a look on that. Sodium, the melting point of it is rather low. It is just 98. Can you see that? 98 degrees Celsius. So in case the reaction is highly exothermic, which means without heat, it will finally melt to a silvery ball. What else? Once I put it into the water surface, the colorless gas, the hydrogen, is be given out. It seems like a propeller, right, to make the silvery ball move. Okay, so you will hear the sound from the video. So what is that? We will describe the sound as hissing sound. Okay, hissing. Hissing is detected. So this is how you may think of some other observable change. That too. This is what you may see and also you may hear. Is it suitable to carry out this reaction in a test tube? Because of that? No. Why? Because the energy released is too high. So you may break the test tube. So that's why the reaction is carried in a very large amount of water. We call it a trough. Okay, 水槽, a type of large places. Okay, a water trough. So this is what I would like to talk to you, or we will call that we describe the word highly exothermic 放熱 to describe. Now finally, suggest how something about the reaction. Suggest how the student can show the resulting solution becomes alkaline. How? You are going to test the solution by what? Yes, you may refer to the concept in Form 2YS. Tested by the red litmus paper. So it turns to blue. Okay, they will turn red litmus paper blue. Of course, you may think of the similar way to do by testing with test the solution by what? For example, pH paper, right? So the similar observation will be seen because it turns the paper to blue as well. Very similar, okay? And finally, from the reaction for magnesium, I put it to cold water, no reaction. For sodium, I put it into the cold water, a very rigorous reaction. Both they are in. We will want to take a look on the periodic table. They are just next to it. Okay, they are also in period 3, but one of them is group 1, one of them is group 2. So the question comes: is sodium or magnesium more reactive? Yes, you can get the answers, right? Sodium is more reactive. So what is the trend? What is the saying? If you want to compare group 1 and group 2 elements, now what I would like to show you like this. Okay, we have got so many substances where you have got group 1 and 2. Okay, if you want to compare the reactivity will both increases down the group, increasing reactivity. However, but once we are going to check it, this is from lithium and beryllium for the first one, and sodium and magnesium for the second one. So when you compare amongst the two, for example, you may see that group 1 elements in the same period, okay, is more reactive than group 2 elements. So what is that comparison? The comparison is made on the condition that they are in the same period. They are in the same period, okay? So this is what I would like to show you for that part, okay? Remember what you're going to talk about that, okay? Remember, same period. You use it as a same period for comparison. Group 1 elements is more reactive than group 2 elements. So the down the group. So what is the description about the trend of metals among the same group? Okay, for the same group elements, their reactivity increases. Okay, so this is the two saying I would like to share with you. Point number 1. Group 1 group elements reactivity of them increases down the group. 2. When you compare with the same period, group 1 element is more reactive than group 2 elements. So this is the end of today's lecture for that part, and I would like to show you group 7 and group 0 elements comparative reactivity in the next video. Bye bye.